Okay, today we are doing slides 8, 9, and 10. So we're going to really we've talked about rotation. Now we're going to look at the difference between rotation and revolution, because that is a really important takeaway for you guys for 5th grade, is to understand the difference between Earth's rotation and revolution, and just understand the difference in general between the terms revolution and rotation. So revolution is a body of object circling around another object. Whereas rotation is more, you can think of it more like spinning. So all of the objects in the sky, and it's important for you to know this, everything has an axis. Everything has an imaginary line, and it spins around that. So everything is spinning. Even the sun, all the stars, all the planets, all the moons. Everything in the sky spins around an axis. Everything is spinning. Only some things are revolving. So for instance, stars do not revolve. The stars stay in one spot, right? They're just spinning in place. They're not moving around another object. Whereas the planets and the moons are actively orbiting or revolving around something else. And so the revolution is the big orbital path. Whereas the rotation is the spinning, like when you spin a top. Okay. So the moon revolves around the Earth revolves around the sun, the Earth rotates on its axis, the moon rotates on its axis, and the sun also rotates on an axis. And so do all the stars, all the planets, and all the other moons. Okay, so revolution. So this movement right here, this revolution movement, takes one whole year. So that is what determines the length of a year for a planet. And so Earth's year is 365 days. That is because it takes us, if we start here, it would take us 365 days to get all the way around the sun and back to that spot. And so it's like that for every planet. So every planet has a different year, and some of their years are shorter than ours, and some of the years are much longer than ours. It just depends on how long their orbit is. So I'm going to just go back and show you. For example, Mercury is really close to the sun, right? It's a lot closer than Earth. And so for Mercury to leave this spot, get all the way around the sun, and get back to that spot only takes 88 days. So 1 year, if you're living on Mercury, is 88 days. And so the planets that are farther out here, they have a much larger orbit. And so it's going to take them much longer to revolve around the sun. And so they're going to have a much longer year than we do. Their year is much, much longer than 365 days. So what determines the length of a year for a planet is its revolution. How long does it take to revolve around the sun? Our year is equal to 365 days. And so it takes 1 year, it takes 365 days for Earth to go around the sun. So that is what determines the length of a year for us and for every other planet, is how long does it take that planet to make one complete revolution around the sun. And so typically, the closer a planet is to the sun, the shorter its year is going to be, because it's going to have the smallest orbit. And the farther away you get, the longer their year is, because their orbit is a lot larger. So Neptune has a much, much longer year than Mercury. But the farther away the planet from the sun, the longer their year. Now, rotation is what determines our day. And just like revolution, rotation is different. The length of rotation is different for every planet. And so our 1 Earth day is equal to 24 hours, because that is how long it takes us to make one complete rotation. But other planets may rotate faster or slower than we do. And so they have a different day length. So our day is 24 hours. That's because it takes 24 hours for the Earth to rotate on its axis. But just keep in mind that the length of a day for any planet is determined by its rotation. Remember that all the planets are rotating, and so however long it takes for them to complete one spin on their axis or one rotation is how long their day will be. Every planet's day is not 24 hours. That is just our day, because that's how long it takes us to complete one rotation. Okay, and so revolution is the big movement, the orbital movement around another object, whereas rotation is more like spinning on an axis. Everything rotates, but only planets and moons revolve. Okay, so to review a little bit about our solar system, there are 4 planets. Oops. Okay, so we have, let me make this a little bigger. We have 4 inner planets. Actually, I do not want that bigger, I want that smaller. So we have 4 inner planets, and I'm going to zoom in here so y'all can see a little better. Okay, we have 4 inner planets, 1, 2, 3, 4. Then we have the asteroid belt separating them, and then we have 1, 2, 3, 4 outer planets. So we have 4, and we call them the outer planets. Now, the inner planets all have in common the fact that they are made of rock. They are all spheres of rock. So they're solid. They have a rocky core. Whereas the outer planets we call them spheres of gas. And technically, I'm going to add ice because they should be. Some of them are made more of ice. So the 4 outer planets are not solid balls of rock like the 4 inner planets are. They are made up of gas or ice. The inner and outer planets are separated by the asteroid belt. Okay. Oops. Okay. Each planet is orbiting. Actually, I'm going to put revolving first. Revolving, or another word for revolving, you could say orbiting. But in 5th grade, we really want to try to use the word revolving. So each planet, revolves or orbits around the sun. Every planet revolves or orbits around the sun. One Earth year, and you might want to move your box up a little. 1 Earth year is the time it takes Earth to, you guys are going to have to add a box here. So 1 Earth year is the time it takes Earth to revolve around the sun. So remember that all day and year lengths are different for each planet. They are different for each planet. Rotation is spinning on an axis. Revolution is orbit around. So the Earth revolves around the sun. The Earth spins on an axis. Okay, looking again at day and night. So we have this arrow showing us that the Earth is spinning on an axis. It technically should be tilted, but for these purposes, we're not. Okay, so this arrow here signifies rotation. And rotation, remember, determines day and night. Revolution determines a year. So if Earth is rotating on an axis, half of it will always be in sunlight, half of it will be in darkness, and we switch off as it rotates, right? So right now, the side of Earth that is facing the sun would be having daytime, and the side of Earth facing away from the sun has nighttime. All right, vocabulary, quickly. So we are just matching words, definitions, and pictures. All right, the time it takes Earth to make one complete rotation on its axis would be day and night. So day and night is determined. Day and night is caused by rotation. The time that it takes us to rotate determines what a day is for our planet, which is 24 hours. And so that would probably be this picture with the 24 hours notated. All right, a line, real or imaginary, around which something spins. So for the planets, the stars, and the moons, it's an imaginary line, and it's called the axis. And so it's this. It's usually shown by a dotted or a solid line in pictures shown slant. And you'll see it's always tilted for the Earth. For different planets, it's tilted to different degrees. But you'll see that it's always tilted whenever we see it in the Earth to this degree, to about 20 degrees. All right, an instrument that shows direction and uses a small magnet to show north and south would be a compass. A dark area caused when an object blocks light is a shadow. So here's a picture for a shadow. And that's gonna become important in a couple of days, in a couple of weeks whenever we look more at shadows. All right, an instrument that measures the time of day using the position of the sun. So this is a sundial. And again, when we look at shadows, we're going to take another look at how sundials work and what they are. So you'll kind of get a better feel for that. But this is kind of a picture of a sundial. It's what was used before clocks were invented. Before people had clocks, they used shadows to tell time. Because if you've ever noticed, your shadows change during the day. They get longer and shorter, and they change directions. And so people used to use that to kind of tell time. And they made a clock face and they watched the shadow move around the clock face and it told them what time it was. All right, and then day, Earth faces the sun. Nighttime, Earth faces away from the sun. That is describing rotation. And here's the picture that goes with that. All right, remember, do not turn this in. Your teacher can see it without you turning it in. You don't need to turn it in for her to check it or see it. She can get it in her Google Drive at any time. So do not turn it in, because if you turn it in, you're not going to be able to edit it anymore. So make sure you hold on to it.